Chabra.
Good afternoon, ladies and gentlemen. It's a pleasure to be here halfway across the world. Thanks to LinkedIn, Captain Sam, and of course to my boss who has sponsored my trip. I was talking to an audience of diminishing returns. I wish I was talking on collision avoidance, which is my pet subject. I've written a book on it. It's available in the Academy with Sam, those who wish to look up. I have not given up sailing yet. Last sailed 2010, and I intend going back at sea as master in June, or, well, it will be June, not May. So since I joined sea in '76, I've seen it all changing. Every time I go out to sea, after a few years, yes, there is change. There's always resistance to change. We did it in the good old ways, and this new way is not good enough. To unlearn the old, get out from the before computers age and get into the after computers electronics. Keep learning new things. So I made a 1-hour presentation, and I'm going to take it in the compressed mode as an e-presentation in the next 18.5 minutes. Hope you'll keep up with me through this roller coaster ride. If you miss out something, a more detailed version will be available on the net. Every data is not here. I want to go back through history where technology did not help. A quick look. I'm not going to discuss each case. This was mentioned before. The first radar-assisted collision. 5 people died on the Andradoria. 15 later died diving to see the wreck. Torrey Canyon, studied a lot about it. They said the master was a rascal. But when you go into the depth, the helmsman switched from, instead of auto to hand, he switched off the telemotor. They couldn't make the turn. As simple as that. It could happen to anyone even today. I've yet seen systems where the controls are so close to each other, it's very easy to mess up. The moment we talk of eNav, it should take you back to Royal Majesty. The cable broke, set went to DR, rest is history. The first VHF-assisted collision. Wrong assessment of ARPA vectors. And at last was the ship handling. When the Norwegian Dream was too close, they went full astern on the propulsion. Increases the turning circle, basic seamanship problem. All combined, they were almost wanting to evacuate the city because of the fire on Ever Decent. These two guys kept arguing whether it's crossing or whether it's overtaking till they collided. And this is chief mates on watch with all the technology, and they're sending teletext messages to each other on the AIS. Very interesting. You should read up the report. Don't want to talk about it. It's happened right next door. A famous incident to talk about. But what I want to talk about is, if all my life I'm used to a symbol on the left, and suddenly on the ECDIS it becomes a symbol on the right, will my mindset register that? And what I wish to point out is, are we getting it too fast? Or our old fogies like me will be able to adapt to the new system as fast as it is expected? Maersk, with very high standards of training and education, had the ship go aground in Singapore, 2009. Disoriented with the scale of the chart. Large scale chart, they thought there was a lot of space. But worse was when they reduced speed, the speed didn't reduce because they did not realize that the load down program works down all the way. These guys thought the island is a cloud and we can go through it. Another one in San Francisco, just to highlight that the recon didn't work, they couldn't navigate. Some statistics, this is the problem, whatever I had thought I'll talk about, somebody else has been pulling away from my presentations, but still, we are losing about 150 ships per year, research by Southampton University. My colleague from AIG talked about losses. For the first time they say twice in the last decades, we've gone down to less than 100 losses per annum. They've also given a geographical view where these losses are taking place. I've been doing a lot of work with Swedish Club, being part of the MRM group, and the statistics I got from them continues to show that collisions are not going down worldwide. In fact, the red line indicates they're going up. So why are these accidents taking place? Is it a failure of risk management, error chain management, human factors, or all combined in any order? The statements in red is what IMO talks about the human factor. Is the most important contributory to the causation and avoidance. And humans have the most degree of freedom to disrupt any system. As morphology says, you can make the system foolproof, you'll get a better fool. Then somebody said, make it idiot-proof. Doesn't make a difference. You'll get a better idiot. So what does the law state? What is the duty of an officer on watch? Prevent collision and prevent stranding. As simple as that. That's what I expect an officer on watch to do, and that's what I'm responsible for if I'm sailing as master. But as master, or any master, when I have to look into the watchkeeping elements, I have to take into account the knowledge, the confidence of the person or the OW, their professional competence, their experience, their familiarity with the equipment, with the procedures. So I have a right to ask the people whether they know the job or not. The same STCW says the OW shall be thoroughly familiar. Very hard-fitting statement, thoroughly familiar. As part of my navigational training, when I ask officers, how does an AIS give you the bearing of the other ship, I get a variety of complex answers. From gyro bearing to magnetic bearing, every kind of answers are up there. If I ask people what are the limitations of ARPA, it's rarely known that the CPA limits for the old set was 0.7 miles, for the new ones is 0.3, and it takes minimum 3 minutes. And I'm talking across the world. I've been doing navigation training from the Far East to Russia for our officers of our fleet. So we need competent people. What is competency? The same STCW says it is proficiency for the proper performance, taking into account knowledge, understanding, and demonstrated skill. That is what the certificate of competency says. ISM adds a little touch to it. This is not only competency, but it is the commitment, the attitudes, and motivation of people at all levels. This is from the ISM preamble. I have not added one word into any of this. While we keep talking competency, the other three are frequently missed out and are quite important. So the old traditional bridge going down into history, we're getting the more modern bridges. In effect now, you see the passenger liners, they have them like this. I'd been on the sister vessel of Costa Concordia as part of my MLC training. Beautiful bridge, very nice ship. In future, it would be a computer lab. Yeah, might be. So that's my last vessel as master, 2010. We sailed from here to Norfolk, then across Atlantic to Southampton. All and all on board is governed by ISM code now. Can't get out of it. I call it the black hole of shipping legislation. You name it and it fits into ISM. Okay. ISM requires an operator or an owner to carry out risk management. And that includes putting appropriate safeguards. And ladies and gentlemen, let me tell you, with a company of 150 ships and my colleagues in other management companies, whenever an accident or a failure takes place, we get a solid bollocking. What have you done to have prevented this accident? And sometimes we are at a great loss to answer some stupid accidents. How much should anyone know? I usually joke about it. 5 wives with that one husband. What are we going to do? When are we going to do? Who's going to do it? How are we going to do it? Where are we going to do it? Just keep applying it and we'll get the answers. How much should a mariner get to know? Ultimately, he needs to know, he or she, to be precise, to get the job done right the first time and every time and then again and again, without any failure. That's what is the end objective. We need not pay any insurance premiums. BP, as a company, does not pay any insurance premiums. The vessels are not insured. They put a lot of effort. I worked in BP for a long time. A lot of effort to train people better, not to have an accident. IMO lists these in their FSA circular as typical human errors. Are these understood? Is risk management taking into account the human errors in educating mariners? Unfortunately, my answer is no. A lot of stuff I studied for exams I never used at sea. And what I do at sea was not taught to me in school. For example, now with no radio officers, no clerks, my third mate takes care of paperwork, but that is not part of his formal education. And if he fills in a wrong ENOA, the US government has a minimum fine of $20,000. So one passport number punched in wrong is a risk of $20,000. So I spend a lot of time cross-checking and rechecking. Human factors. The same IMO circular lists them as personal, which says not knowing the controls, not knowing the equipment, communication. I know of a joke, a real one. The master asked for plain curd, and the steward brought him playing cards. Organizational and leadership factors, task features, complexity, automation. Does the person know the operating parameters? Ergonomics, human-machine interface, already talked about. I'll skip and go ahead. Human mind is complex. It's driven by our knowledge. More than that, it's driven by our past experiences. An experience you only get by experience. There is no shortcut to that. How would you like to see this great African or Indian elephant? How many legs has it got? I'm still confused. Walking forward or walking backwards, matter of perception. E-navigation has its roots in commercial aviation. They've done a fantastic job, but a lot of differences exist. An aircraft captain after landing off a long flight goes to a five-star hotel. Me as master have to deal with the agent, the immigration, the customs, CBP, port state control, superintendent, vetting inspection, cash delivery, provisions, stores, crew joining, crew signing off somebody to go to the hospital. I unfortunately don't get the free time, which I should have. But they have a fantastic safety record. The last mid-air collision of commercial airliners was, as I could find on the net, was September 2006. Before that, July 2002 was near New Delhi. Kazakhstan and Saudi Arabian airliners. I mean, fantastic. I wish we could have that for maritime collisions. Aviation is strictly controlled. There's ATC monitoring, there's separation zones, collision avoidance is automated. Somebody already spoke about it. Pilots are monitoring navigators. Marine OOW is still a navigator who's to plan and act. And that makes it a world of difference. Marine aviator, I would say marine navigator is there on board. He doesn't go home. Part of my job I keep doing is navigation training, and just want to share one of the statistics. I showed you a slide, Hyundai Dominion Skyhope collision. So when this situation is put up to people to answer, in good visibility, we get 56% correct answers that this is a crossing situation. 28% say overtaking, and 16% are confused. Change the scenario and say this is restricted visibility. The correct answers drop substantially. And this is covering almost 480 navigators. I would say 80% from India, 20% from Europe. So I did this survey in Riga and Odessa and even in Almere, where I went for training to see the Carnival Cruise Lines coast last year. E-navigation, as I see, is taking us into an automation syndrome. You're going to get a lot of information, or rather overload of information. Instead of searching for it, we get it on the platter. We need to analyze it, monitor it, use it. It'll lead to blind faith in the system, failure to recognize the modes, failure to recognize failures, and that is the most serious problem. Some of the examples in the past I showed you were to deal with this. It will deceive human beings. Already they talk of automation surprises, automation addiction, over-dependence, and this, only one person used the word earlier in this whole presentation, is leading us into a complacency trap. If you Google complacency, you get thousands of hits. You try and Google solutions to complacency, you only get a few hundred, and no clear answers. Take this as an example. IMO standards are there, but no two manufacturers seem to have the same looking ECDIS. Even my computer keyboard looks similar, but not the ECDIS systems. It is quite complex. I mean, the base layer on which we start itself is not safe for navigation to start with. The operator has to go to the safe working layer. Radar systems. This is from a presentation made by a pilot in Southampton for a Nautical Institute seminar in 2009. I borrowed it from his presentation. 4 different manufacturers have got 4 different systems, color schemes, and if you just want to look for heading and speed, you get it in 4 different corners. Marine systems, unfortunately, don't have the standardization which aviation has got. A Boeing 737 pilot only goes to Boeing 737. He's not told, tomorrow morning the Airbus pilot is missing, can you please fly this aircraft? It doesn't happen in marine. My next ship may be totally different than my last ship. Ergonomics. Eagle Autom accident, if you look up the NTSB report, when the master wanted to bypass the load limit, he unfortunately pressed the emergency stop. Whatever little action he could have taken, he stopped the engines. Look up Eagle Autom report. It was a major P&I club oil spill near Port Arthur a few years back. So as automation sets in, and I don't know the system, that is where the OW will get out. He'll become a mute spectator. Sorry if I'm sounding like a devil's advocate, but these are the factors we need to look in as we move from traditional navigation to automation. Aviation is having the same problem on automation. Air France Airbus crashed into the Atlantic, and the comments were, "Our airline pilots forgetting how to fly?" The middle paragraph, they program navigation computers rather than fly manually. In fact, after these incidents, the investigators are recommending to give the pilots more manual flying experience. Asiana Airlines, which crashed here in San Francisco, had the same comments. They're relying on automation to fly the planes. The moment the automation was not working, they were unable to land the aircraft manually. And this, ladies and gentlemen, is a serious problem. If automation fails, are the people ready to take over manually? So, in comparison, if I take an OW as an operator and compare him with a truck driver knows that the forward section of the vehicle takes a longer turn, longer radius, and the rear end a smaller radius, and he uses it in driving, reversing, etc. Knows it, uses it. He may not realize that the rear axle, the 2 wheels are turning at different RPM, and there is a gyroscopic differential working there. He need not know it. Same similarly for OW. Should be competent, apply the 5 wives and 1 husband principle, should know the limitations of the equipment, should know the operating modes, is educated to take into account the human factors, take into account the risk management factors, not fall prey to automation syndrome, which means manual practice is required, and gets the job done right the first time and every time. How will we achieve this? Education and training? Yes, I'm sure all will agree. It'll cost money, time, effort. I'm sure you all will agree. Would it be passive learning? Should it be video screening? Or should it be to do hands-on practice? The Chinese proverb, very ancient, says the last line, only when you do you understand best. If you want to know the subject better, start teaching it. You'll definitely improve on it. From the country I represent, this was the traditional way of education, the senior teaching a junior. In the e-navigation context, I think it could be the other way around. I fully agree with the president of Chevron Shipping yesterday. The juniors have to teach the seniors. My son can do a lot more with electronic than I can. When I need to download a movie, I ask him to do it. I represent Anglo-Eastern Ship Management. We do a lot of work on maritime education and training, starting from pre-sea to post-sea. These websites will be available on the net or on the PDF, which will be put up on the net. Please do look it up. We have a huge campus of pre-sea education at Karjat, 100 kilometers from Mumbai. I'm involved with that at times. We have post-sea centers starting from Manila to Odessa, wherever we have seafarers coming in from. And that's part of my job, to go around these places. Next month is 2 weeks in Manila. Wife is not too happy, going alone this time. A real photograph of a vessel departing Southampton. I wish e-navigation could help us with that. But then if you see the red enhance, there's a hovercraft, a tugboat, and a pilot boat going with whistles to show away the sailing boat so the oil tanker can sail out. There have been a lot of comments, how much can we control from ashore? So I've been changing my presentation, and Sam was fed up. He said, make up your mind. I said, no, this is one more version. This is the last. This is what SOLAS says. It leaves the final responsibility in the hands of the master. And I've been joking about it. If I'm the master on board, I would certainly like that responsibility and decision-making with me than to give it to anybody else, except a qualified pilot. I can promise you, I've been a pilot for a year, and when a pilot is there on board, I usually don't interfere. So if you are on board my ship, you'll have a jolly good time. Okay, that's the end. Thank you very much. I hope I managed the time. Thank you. Bye-bye.